Introduction to motion. What do you think of when you hear the word motion? Are you moving right now? You may not think so, but you are. Remember, the Earth is moving around the Sun, and the Sun is moving around the Milky Way galaxy. Everything in the universe moves. From the atoms that make up all matter to the largest of objects, all things are moving. Motion is defined as a change in an object's position over a given period of time. Whether or not you perceive an object to be moving depends on your point of view or point of reference. An object is in motion if it changes position relative to a reference point. A reference point is a place or object used for comparison to determine if something is in motion. Have you ever been sitting in a car stopped at a red light and seen the car next to you moving and thought that the car you were in was moving backward? You were using the car next to you as a reference point and assumed that it was sitting still. It is important to choose your reference point carefully. Building and light posts are good reference points because they are stationary. The study of motion is a large part of physics. Scientists use words like speed, velocity, and acceleration to describe motion. In this lesson, you will learn the differences in these motion concepts. If you look in your document, you are going to see that it is going to ask you to define some of the terms. Any terms in blue, you can hover over and it will give you the definition. For example, velocity is defined as the measure of speed in a given direction, while acceleration is defined as the rate at which velocity changes. What is speed? You are probably familiar with the concept of speed. Speed is a type of rate. A rate tells you the amount of something that occurs during a given unit of time. If you know the distance an object travels in a certain amount of time, you know the speed of the object. For example, if a car travels 70 miles in 1 hour, the car is traveling at a speed of 70 miles per hour. If the speed of an object does not change during its motion, the object is traveling at a constant speed, which can be defined as the speed of an object that does not change. Most cars are equipped with cruise control. Cruise control allows a car to travel at constant speed. Most objects do not move at a constant speed very long. Most moving objects change speed many times while in motion. The marathon runners pictured here do not run at a constant speed during the entire race. At the starting line, there are many runners crowded together, so the runners are forced to move slowly. As the crowd thins out, a runner can increase his or her speed. The runner may slow down as he or she climbs a hill and increases speed going down the hill. When the race is over, a runner may calculate his or her average speed, which can be defined as the total distance traveled by an object divided by the total time traveled. The average speed of an object tells you the average rate at which it covers distance. You will learn more about the average speed and how to calculate it in Lesson 4 of this module. What is velocity? Have you heard the term velocity? Many people often use the terms speed and velocity interchangeably, but speed and velocity are different. Look at the statements below. What is the difference in the statements on the cards below? An airplane is traveling 804 kilometers per hour. An airplane is traveling eastward at a rate of 804 kilometers per hour. One of the statements describes the speed of the airplane and the other describes the velocity. We can click the cards to see which statement is describing speed and which one is describing velocity. So you notice the one that was describing velocity had the direction in it. When you know both the speed and direction of an object's motion, you know the velocity of the object. Now we're going to practice distinguishing the differences between speed and velocity. In this activity, we are going to look at statements and determine if the statement is describing speed or velocity. Remember, speed refers to an object's change in motion over a certain period of time, whereas velocity is the change in motion over a certain period of time, but it also includes direction. Our first statement says Jackson ran 5 kilometers in 2 minutes. Think about what the answer is and pause the video if you need to. So that's a speed. There's no direction associated with it. Our next statement reads, a train travels 90 kilometers in an hour. Again, pause the video and think about which one this describes, speed or velocity. This is also a speed. There's no direction associated with it. A storm is traveling 2 kilometers per hour eastward. This one's velocity because we have the term eastward. Juan walked 420 meters in 17.5 seconds. If you said speed, you're right. There's no direction attached. Amy moved the desk 34 centimeters to the left. That one is velocity. We have the term to the left, which is a direction. There are more here, so feel free to go back to this and try out some of these interactive questions on your own. What is acceleration? As discussed in section 2, the speed at which an object travels can change. An object can increase in speed or decrease in speed. The direction an object travels can also change. A car can travel north for 20 meters and then turn right and travel west for 50 meters. When an object changes speed or direction, we call this acceleration. Acceleration is the rate at which velocity changes. Remember, velocity has two components, speed and direction. We're going to practice now. We will identify the following statements as either having acceleration or no acceleration by clicking in the appropriate box. Our first statement reads, a box travels on a conveyor belt that is moving at a constant speed. So in order for an object to accelerate, it has to change speed or direction. They use the term constant speed, so we know that it's not changing speed. It doesn't say anything about this conveyor belt having any type of curve or change direction, so we can assume that it's going straight. In this case, the box is not accelerating. It is not changing speed or direction. Our next one reads, a car travels on a winding road at a constant speed of 60 miles per hour. Again, we can check, is it changing speed? Well, it says constant, so no, it's not. But what about direction? Well, the car is going on a winding road, which means that as it winds down this road, it will be changing its direction. Therefore, the car is accelerating. The next one states, Dalton swims laps in the pool at an average of 2 laps per minute. This one, we have to think about the word average. If we have an average speed, it's very likely that Dalton is not consistently swimming at the same speed the entire time. Not only that, but if you ever swim in a pool, you know that in order to do a lap, you go back and forth in the pool, which is a change in direction. So Dalton is accelerating. For the rest of them, read through and see if you can figure out if there is acceleration or if there is no acceleration on your own.